Let's try some word association. I'll say a word. You just say the first word that pops into your head. Ready? Day.
Day after day, the Earth is worn down by water, ice, wind, and chemicals.
Night.
Night after night, the process continues, relentlessly, unabated, pounding on the Earth.
Interesting. Dog.
Doggone it! That mountain used to be higher and more jagged.
Aha! I think I see the problem. It goes back to your childhood. You are obsessed with erosion.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Erosion Demolition, Inc. Give us the time and we'll wear away anything you got.
Rocks are solid. They're rocks. But every rock on the Earth's surface will be different tomorrow from the way it is today. They're eroding. Water, ice, wind, sand, and chemicals are constantly crumbling mountains, flattening hills, widening valleys, and deepening canyons. Erosion never stops. Never! Whoa! Wrong way. Take a look at this. It's our water flow erosion model of science. It's a piece of mineral salt and a hose. Now watch what happens when a stream of water slowly flows over it. It's changing. The water is carrying some of the solid away. We say it's eroding. Now this takes time. This is our expanding ice bottle of science. When we freeze the water inside with this ordinary household liquid nitrogen, the liquid water turns to solid ice, and it expands. It can split the bottle right open. See? Now, when liquid water gets in cracks and rocks and freezes, the rocks split open. This is another cause of erosion. Well, it's coming along. See, the rock is changing. Very, very slowly. Changing. There we go. Zip up.
Now look at some wind erosion. This is sand. This is a sand blaster. Let's say that these plastic foam mountains are, mountains. What? See, every particle of sand carries away a little bit of mountain. So that after a while the mountains change. They're eroding. Okay. How do I fix that? Hello? Hello? Anybody?
Got a chip on your shoulder? Slough off life's worries the natural way at the Erosion Spa. Let our staff of skilled erosionists chip away and take off life's craggy peaks. Enjoy a wind and sand exfoliating scrub. Relax in an acid rain soak and smooth away wrinkles in the chemical erosion chamber. So when you're feeling jagged and unstable, set aside lots of time and come on down to the Erosion Spa.
Okay, I'm gonna tap real hard. Phew. Sand in my mouth.
Look, the water has worn a little canyon. See how deep it is? Landscapes all over the world are always changing. It's erosion.
When it rains, the water that falls erodes the earth. Here's an experiment you can do to see how erosion works. Put some damp sand in a container like this. Dump it out like you're making a sandcastle.
Nice move.
Put a quarter flat on top of the sand. Sprinkle some water on top of the sand very gently.
Very, what did you say again?
I said gently.
Oh, yeah.
See, the sand washes away in every place except underneath the coin. The coin is like a plant, or a tree in a forest, or a really hard rock, which helps prevent erosion. When there's something holding the soil in place, it doesn't erode as fast.
See this dark color? It's iron oxide, rust. There's iron in the rock. Rainwater and oxygen in the air combine to turn it into rust. It leaves these dark streaks on the rock. Let's say this is a rock. Well, it is a rock. And let's say that this is iron. Well, it is iron. It's steel wool, which is mostly iron. This is hydrogen peroxide, a chemical made of water and oxygen. As it flows over the rock and hits the iron rusts and leaves streaks, just like the streaks on the rocks outdoors. It doesn't matter if the metals in rocks are in human-made objects. Rainwater and fog are helping this metal combine with oxygen in the air. It's turning this copper green. It's slowly eating the metal away. It's just like the rocks. The iron turns to iron oxide. It's taking some of the iron out of the rock. Some of the rock is going away. It's a form of erosion. It's chemical erosion.
Tonight on Erosion.
What's this? Statue of Liberty, worst example of chemical exposure I've seen in years. I count. 1, 2, 3. Oh my gosh, oxidation. This copper is entirely green. Somebody give it polish. Good green stat. I think we even made this one in time.
When you have layers of different kinds of rock, erosion can happen from the inside out. If softer rock happens to be underneath harder rock, we can end up with a shape like this. The softer rock erodes away first, leaving an arch.
Quit monkeying around, Bill.
As the wind blows across the high desert, it picks up sand. The sandy wind erodes these rocks.
A highly magnified view of several sand grains shows their sharp cutting edges. Such hard quartz grains cut into solid rock when blown across its surface.
Since the wind can only pick the sand up so high, it only erodes the rock so far. We call these mushroom rocks. They're formed by wind erosion. A stream has cut through this sandstone. The running water picks up sand grains off the stream bed and carries them along. The sandy water acts like a scouring pad, wearing its way down, year after year, year after year, year after year, and carving this canyon.
Erosion is the slow wearing away of the Earth's surface, kind of like what I'm doing here, but for millions and millions of years. Yes, millions and millions of years!
Waves are relentless. They pound, 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 pound on the shore. And when they do, the force of the wave bends the rock and makes it crack. The continued force of the wave makes the cracks get bigger. And eventually, pieces of the rock fall away, leaving these. They're called sea stacks. That rock, in fact, all the rocks around here, used to be part of this hill. But the force of the waves has knocked them all loose. And I'll tell you what else. Another few million years, all of these rocks will be reduced to sand. Sand like this. See, here at the beach, the waves have been pounding on the pebbles and making them rub on each other for tens of thousands of years, turning them into grains of sand.
Now, when you look at the shoreline, you can see that it's a narrow strip of sand. That's because the waves only pound their way so far inland. But look, they're turning rocks into sand, for crying out loud.
It's erosion.
Welcome back to Pet Rock Theater. Tonight's episode, Grandpa smooths things out.
Grandpa, how come you're so smooth and I'm so rough?
Why, you just haven't undergone much erosion yet.
Erosion?
Here, let me show you. When I was your age, I was a little rough around the edges, too. But after millions of years of sand, wind, and waves pounding on me, I got smoother. You will, too.
Wow! You mean I'll be smooth like you?
Righty-o.
Will I have a gray beard and red iron oxide streaks, too?
If you're lucky.
Nice view, but at what price? This house is built on the side of a hill, an eroding hill, and it's steep. When the soil got soaked with rainwater, it broke loose in big slabs. Now, if a house happened to be built on a slab and the slab came loose, well, the house went with it. Now, people can slow erosion down by designing concrete barriers, putting up plywood fences, and installing drainage pipes. They have to do all this extra work to live here with this great view. It's a choice they make. But sometimes they have to move because fighting erosion can be an uphill battle.
Tonight, on a very special episode of Eroda.
Hey, Faye, this whole city just isn't what it's cracked up to be.
Can a single girl make it in a big city that's eroding before her eyes?
The seed that this tree is growing from landed in a tough place a long time ago. Now, right now, the roots up here are holding back rocks and soil. And the roots down here are strong enough that as they grow, they can split rock apart, helping break it down into soil for other plants to grow in. See, this tree is holding back soil, but the rock is still eroding away. So in one way, the tree is slowing erosion down. But in another way, it's speeding erosion up. See, living things are part of the process.
Tonight on MacGoober. MacGoober is trapped in an abandoned warehouse, but don't think he's licked yet.
I'm not licked yet.
Erosion. Now I just have to sit back and wait for erosion to dig through the floor.
Erosion girl, she'll wear you down. Rain, wind, and sand are blown around. She's erosion girl, and she'll rock your world.
Look at this! Look at this! It's erosion! Erosion! Wind, rain, sand, ice. It eats away. It attacks rocks and mountains. It takes millions and millions and millions of years. It never ends! So suck it up and deal with it!
MacGoober.
Oh, yeah. Now we're getting there. Another 10,000 years ought to do it.
Don't miss MacGoober on NITV right after.
See these layers? This hoodoo. See this little arch? See this window? See those grottos? See these rocks? Well, take a good look, because they didn't look like this yesterday, and they won't look like this tomorrow. In fact, they'll never look exactly like this ever again. Here's why. Every once in a while, it snows around here. Then in the morning, the sun melts the snow, and the water flows down between cracks in the rock. Then at night, it freezes again and expands. That forces the rocks apart, makes them crack. Now, as the liquid water flows over the rock, it dissolves some of the minerals. That's why we see these different colors. Then this green color and this black color are plants called lichen, and they're feeding on chemicals in the rock. So the freezing water, the chemicals, and the living things are all eating away at the rocks.
Mm-hmm. You hungry, Bill?
It may not seem like it, but this process is happening every day. It doesn't ever stop. The walls of this canyon erode about that far, this much, about half a centimeter every year. Now, how far do you think they'd erode in 100 years? It'll be about that far. Well, then in 100 centuries, it'll be close to a soccer field. Well, just think of what would happen in 1 million years or 15 million years. You can see that one day, this place won't look anything like the way it does now. You see, erosion is a never-ending process.
When water freezes, it expands, and that can cause erosion. Try this. Take some modeling clay and smooth it into a ball.
A little faster if you could.
Like this.
There you go.
Put your ball in a plastic bag and place the whole thing in the freezer overnight.
All right. The next day.
Let it thaw, and then place it in the freezer overnight again.
Mm-hmm.
Then let it thaw and freeze it again. Now I've frozen this piece 3 times.
I know.
See, the clay cracks up all over the place. Water in the clay froze, it expanded, and then split the clay apart. Same thing happens with rocks. Water gets in the cracks and freezes into ice. The rock erodes a little bit more every time the temperature dips below 0. It's erosion.
See the crack in that wall?
Uh-huh.
Hoodoo in progress.
Hoodoo.
That's a hoodoo, a column of rock. It started out as part of a vertical rock wall like that one. Then year after year after year, year after year after year after year, water worked its way into cracks and froze. It made big wedges slough off, leaving hard rock behind. The hoodoos, they're spectacular. Hoodoo! 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 Hoodoo!
Every mountain, rock, and hill wears away, erodes until it's sedimentary sand carried off by rain and wind. Ooh, it's a change that doesn't happen fast. That jagged edge won't last. Pounding water, wind, and ice over falling rain. They're all causing the erosion. Even chemicals we know that are in the air. They're all causing the erosion. Surface of our planet Earth. Mountaintop and rocky cliff, eroded by the elements, it's a well-known fact. Pounding water, wind, and ice over falling rain. They're all causing the erosion. Even chemicals we know that are in the air. They're all causing the erosion. Pounding water, wind, and ice over falling rain. They're all causing the erosion. Even chemicals we know that are in the air. They're all causing the erosion.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some benefact abrasion coefficients to delineate. See ya!
Produced in association with the National Science Foundation.
Woo-hoo, Steve! Oh, sure, Steve. It's been washing for thousands of years. Look at this. Oh, man. Look at these things. Look at the size of these things. It's kooky. They're beautiful. The benefaction that happens every day this time of year. Look at this huge, huge wedges of material that get sloughed off every morning. Not every morning, but I mean slowly. You're looking good, but you know, another 1,000 years, I don't think you're gonna be here. Yep, I think you're gonna be long gone. There you are. Nothing I can do about it, my friend. You're a rock, I'm a human. You'll be here after I'm gone, I guess, but I can see it coming for you. Yeah. Let's look over here. In your neighborhood right now, there's erosion going on. And this scene today will never be exactly like this again. It's eroding.